Are you willing to learn Einstein's field equations, general theory of relativity, black holes, gravitational lensing, space-time curvature, and all those mysteries of the universe? If you are looking for that, then this is the right video for you. And most importantly, this video does not contain too much of difficult mathematics like tensor calculus, differential geometry, partial equations, and all those. Yes, this would be the right video for you. In this particular conversation with me and Divyansh Gunjan, the founder of Whimper podcast, I have discussed everything that is required to learn about general relativity and the history of general relativity with some fascinating and motivating stories from the pages of history. So as you can see that this video is basically a wonderful conversation from which you can learn everything about general theory of relativity, black holes, and whatever you are looking for. So you can see that this is basically a more than an hour's discussion. This is part one of the video, and I have given the original video's link in the description. You can go and watch it. So I have started basically with Isaac Newton, starting from classical mechanics, how he framed the mechanics and the philosophy in Naturalis Principia Mathematica. After that, how Maxwell's equations turned the pages of history, followed by Isaac Newton. So this is a very good thing. And what are the things that you will learn? You will learn something about classical mechanics. So obviously I have started dealing with classical mechanics, the limitations of classical mechanics, and most importantly how Isaac Newton formulated Principia Mathematica. There is a wonderful story about how Edmund Halley actually helped Einstein to publish this Principia Mathematica at the Royal Society, but because the problem was that during that time Newton was not having money, or well, I won't say right now. You can look into this video. There's a wonderful thing which you can learn about Edmund Halley and Newton's friendship. I have also talked about the advent of modern physics, how modern physics actually came in. The first unification, that is the formulation of the Newton's law of gravitation, that is called the first unification theory, and how and when Albert Einstein arrived and what is his further contribution. Further to this, I have also discussed about the evolution of special relativity and general relativity, which is very important because we do not understand general relativity until we understand special theory of relativity. So you can understand here, I would say, quite a lot that I have talked about special relativity, the history of general theory of relativity, which is a very important thing. Those who are watching this video and those who are my subscribers, I have always told that you need to understand the history of any theory, any mathematics, without which your understanding will not be complete. You will always find that those complex mathematical equations are meaningless. They have got no objective in front of you. This is something important. I have talked about that a cloistered office at Bern, Switzerland, when Einstein was sitting at the patent office, and how suddenly he got that golden thought that if the floor collapses and it starts falling, the accelerated frame and the non-accelerated frame of reference. So here you will understand how Einstein actually created relativity. I have also defined what is gravity in modern physics, talking from Newton's theory of gravity being a fictitious force. Even Newton was not quite, I would say, happy or comfortable in defining gravity in mathematical terms. But during that time, the limitations of physics and the theoretical part of mathematics which we had. So what is gravity in modern physics? I've also, discussed about Einstein's field equations, but the second part contains a lot more about defining each and every component of Einstein's field equations. I've also talked about what led Einstein to think about general theory. So I have discussed, you can get what is the meaning of field equation, and most importantly, what does it look into, because we know that field equations actually describe space-time curvature, but what that curvature is, that would we be able to understand and measure curvature in our daily life? What is space-time curvature? Yes, I have talked in details about tensors, but not on a very mathematical way, the history and development of tensors. Most importantly, I have also tried to remove the misconception, because you see what happens whenever we are learning general relativity, astrophysics, cosmology, there is a kind of an misconception that we will fall inside the black hole and then we get outside and we will enter into possibly a COVID-free world. What will happen if things start accelerating at the speed of light? So these are certain misconceptions. You can hear it out there, and I have cleared those misconceptions, and most importantly the summary I have given, and looking forward, that is the second part. So the second part video is not out. I will put up again a small kind of a video where you can hear about the second part in an audio format. This is Divyansh channel. He's a new young guy and is doing quite a good thing about that. You can see here that there is some conversation with somebody from NASA about microgravity and how to survive on Earth. So there is a lot of interesting stuffs going on in this channel. And these are some of the funny moments, I would say lighter moments, which I've given from the video. So you can look into it. This is a kind of a nice learning, I would say easy learning method. History, lot of conversation, lot of interesting stories given with some motivating factors also, and you will learn almost everything about modern physics, not with the particle physics but with Newton's and relativity. So I hope you will like this conversation. Please let me know into the comment box, and thank you for watching this video.